Good morning, good afternoon, or good evening, depending from where you're attending this lovely online conference. Um, Today, I want to talk to you about test-driven development. And without further ado, let's get started here. So, why we quit unit testing classes to focus on a behavioral approach? Unit testing is evil. Unit testing is overrated. Why most unit testing is waste. Mocking is evil. Stop making and mock things. All your mocks are evil. Now, the interwebs is full with blog posts like these, and every time I encounter such a blog post, it somewhat bothers me. It's not that these articles should be ignored. Quite the contrary. Some of them even present a pretty good case. However, all these blog posts all suffer from a common issue. And that issue is that they are too superficial. It's not easy to understand test-driven development, let alone to teach it. It's also impossible to give generic advice when it comes to test-driven development. I'm not going to state that I'm the oracle of wisdom here, although I have quite some experience by doing this practice. Nonetheless, I do notice a fundamental lack of deep understanding about a simple practice like test-driven development. Now, you might have heard about the person Simon Sinek, and he uses this concept of the golden circle. And it states that there's a what, a how, and a why. And when applying this concept of the golden circle to the issues that developers face with a practice like test-driven development, let's go over the what, the how, and the why. First, we have the what. And developers sometimes find it difficult to write tests. And then tests fail unexplainably from time to time. It's also sometimes difficult to refactor our code without breaking tests. And sometimes tests are also difficult to understand. These are general problems that many developers struggle with. And then they look at the how. And then they find out that unit tests are tightly coupled to production code, and that test doubles are misused and or wrongfully applied. And at that point, most developers stop and jump to conclusions. Unit tests are hurtful. Let's only use higher level tests instead. And sorry, I'm having some difficulties here with my slides. Sorry for that. Quickly. Okay. At this point, most developers stop and jump to conclusions. Unit tests are hurtful. Let's only use higher level tests instead. And test doubles are evil. Stop using test doubles. And this is where those clickbait blog posts come from. Most people are focused on what and how and forget the most important thing, why. Why do developers complain about unit tests and test doubles? Now let's take a step back and revisit the origin of test-driven development. There's this well-known paper about software engineering that dates from 1968. And that paper also describes the concept of test-driven development, so it's quite old. It mentions the following sentence. Software system can best be designed if the system is interlaced with the designing instead of being used after the design. There's something very specific about this sentence. Sentence contains the word design 3 times and the word test only once. Personally, I believe test-driven development should better be called consumer-driven development. It's driving the design of the system by exercising every single part. And then a few years passed by, and at the beginning of the new millennium, a book appeared that made a profound impact on our industry. This book is the first edition of Extreme Programming Explained, written by Ken Beck. Extreme programming is a development methodology used by Chrysler's C3 project at the end of the 1990s. The term test-driven development comes from extreme programming. Now, Ken Beck claims that he didn't invent test-driven development. He stated that he merely rediscovered it. And if you open the book at chapter 18, it starts with the following statement. We will write tests before we code, minute by minute. We will preserve these tests forever and run them all together frequently. We will also derive tests from the customer's perspective. Now, this implies that there are 2 types of tests, developer and customer tests. We'll get back to that later on. Now, the most important parts from this paragraph is that write tests before we code, minute by minute, and run them all together frequently. And this brings us to the raison d'etre of all extreme programming practices and therefore also test-driven development. And that raison d'etre is fast feedback. By using the process of red-green refactor, we keep the amount of unexecuted code, which can be considered a work in progress, to an absolute minimum. That way, we quickly find out whether we have working software or not. Now, when we talk about unit tests, they very quickly amplify any kind of bad design in the system that we're working on. They're especially hurtful when written after the production code. Pain, whether we like it or not, is a form of feedback. And then developers start blaming unit tests when there's bad design in the system. And then messengers get shot. And developers say, okay, my design here is just perfect. Thank you very much. And then I refer back to the golden circle. That's focusing only on the what and the how, and almost never the why. Same goes for test doubles. If the production code is poorly designed, then using test doubles will amplify this tenfold. Test doubles are then again blamed for bad design. Messengers get shot, and then developers say, you know what, my design is just perfect. Thank you very much. And then I'll refer back to the golden circle again. That's only focusing on the what and the how, and almost never the why. Test-driven development and software design are 2 sides of the same coin. What we need as an industry is a much deeper understanding about the different aspects of software design and their trade-offs. With that also comes the need for a deep understanding of test-driven development and other extreme programming practices for that matter. So a deep understanding comes mostly from deliberate practice. We have to remember that test code is equally important as production code. So therefore, tests need to be designed with the same care as production code. Only that way we can avoid the cargo cult of unit tests are hurtful and test doubles are evil. Now, let's go over some concepts. In the world of automated tests, there's a lot of terminology. we have unit tests, integration tests, integrated tests, API tests, database tests, smoke tests, component tests, contract tests, end-to-end tests, acceptance tests, UI tests, performance tests, regression tests, approval tests, and the list goes on and on and on. And they all have their usefulness. But which kind of tests are applicable to your work? We need a more useful model for categorizing these tests. In 2003, Brian Merrick came up with the concept of the testing quadrant. And the testing quadrant has 4 quadrants, which is a big surprise for many. The first quadrant in the lower left corner is the developer tests. These are tests written by developers. Big surprise there as well. These kinds of tests are mostly automated. Then we have, in the upper left corner, we have functional tests, which are mostly automated as well. This is what Ken Beck referred to as customer tests. These tests are basically used to prove our customers that our system supports a certain capability. Then in the third quadrant, in the upper right corner, we have exploratory and usability tests. These kinds of tests are mostly manual. And then finally, in the lower right corner, we have performance tests, security tests, and also things like production monitoring, which can be considered a kind of testing as well. And these are sometimes manual, sometimes automated. It depends. Now, when we look at this testing quadrant, the top 2 quadrants, functional tests and the exploratory usability testing, are concerned with tests that are obvious to business users or to our customers, while bottom 2 quadrants are meaningful for the development team, technical people, also the operations team sometimes. And if we look at the left 2 quadrants, the developer tests and the functional tests, these are focused on preventing defects before or during coding, while the right 2 quadrants are more focused on evaluating for defects or missing features. Most software systems will involve tests from all 4 quadrants at some point. And in this talk, we're going to focus on developer tests, which are situated in the bottom left quadrant. In that category, in that quadrant, we have 2 broad categories of tests. Let's call them solitary tests and sociable tests. Now, I didn't invent these terms. I didn't invent solitary or sociable tests. I've adopted this terminology from the book Working Effectively with Unit Tests from Jay Fields, which I highly recommend. Now, what are solitary tests? Solitary tests have 2 constraints. First constraint is that the code being exercised by these tests never cross the process boundary in which they are executed. Secondly, second constraint, a single class, module, or component is being tested. This is also called a subject under test, or SUT for short. Now, what's a sociable test then? A sociable test is a test that cannot be classified as a solitary test. They're more coarse-grained. They exercise multiple classes, modules, or components, and they are more focused on collaboration and integration of the different parts of the application. Now, let's have a look at the test pyramid. The test pyramid was initially described by Mike Coll in the book Succeeding with Agile. And the concept of the test pyramid is as follows. At the base of the pyramid, you have 80 to 90% solitary tests, the majority. And then somewhere in the middle, we have 10 to 20% of sociable tests. And then at the top, we have a handful to a dozen broad system tests. The more we move up the pyramid, the more integration we test, the more slower our tests perform. And at the base of the pyramid, where the solitary tests reside, we have the most isolation and therefore also the fastest performance. My advice here, never to bet on a single category of tests. We need both solitary and sociable tests. Solitary tests for fast feedback, especially when using test-driven development, and sociable tests for verifying correctness of interactions. Again, a quick reminder, the test pyramid is mostly situated in the bottom left area of the testing quadrant. Only UI tests might have a slight overlap with function tests. At the foundation of the test pyramid, it's all about driving the design of the smaller parts of the system, while the upper part of the test pyramid is about testing the system as a whole. These are two completely different activities and mindsets. Now, I do a lot of consulting, and lots of teams make the mistake of applying a pyramid that is upside down. And then they call me and they bring me in as a consultant. And then I do some investigation and I notice that there are more sociable tests than solitary tests. This is also called the inverted test pyramid or the ice cream cone pattern. And this approach is mostly driven by those blog posts that I mentioned on the first slide. Having too much sociable tests and UI tests is quite problematic because they have some significant issues. First issue is that they can be non-deterministic, and non-deterministic tests undermine developer trust. They kill productivity and motivation. Secondly, they make failure diagnostics difficult. Why is that? Because they are further removed from the cause of the failure. They require debugging, in that case, which results in more time being spent. And unfortunately, in our industry, time is money. They also usually cross their process boundary, which makes them time-consuming to execute. They also require more time and effort to put in place. They don't provide useful feedback about the design of the system because they are, as already mentioned, further removed from the details, and design flaws go unnoticed and aren't fixed. And lastly, slightest change or bug in the production code can sometimes cause a high number of failing tests that seem to have no direct relation to the change made. There are other models besides the test pyramid and the ice cream cone pattern. And one of them is called the testing diamond, which suffers from the same kinds of problems. And then there's another model called the testing trophy, but let's not go there either. Martin Fowler has a very nice statement about these. He calls them misshapen blobs. So how do we end up with such a misshapen blob? G.B. Rainsberger has a great talk titled Integrated Tests Are a Scam, which is something that I highly recommend. You can find it quite easily on the internet. In this talk, he mentions the concept of a positive feedback loop of negative emotions. And it goes a bit like this. Let's suppose we have a team that works on a system and they have 100% passing solitary tests. However, they still have bugs. And why is that? Because solitary tests don't check for integration. And then someone comes up with an idea. Let's move away from solitary tests towards high-level integrated tests. So what happens next is that more integrated tests are being added. They take more effort, and they don't criticize the design as much as solitary tests do. Now, at that point, these tests no longer give us fast feedback nor strong feedback about our design. The design then gets more sloppy because we don't notice it happening. And the more tangled the design becomes, the harder it becomes to write good solitary tests. So what do? We write fewer solitary tests and more sociable tests. And then the probability of bugs increases. So, to conclude, having too many sociable tests means less time for solitary tests. This puts things in a state of unbalance. And let this be the title of my talk here today, that we need a good balance. Sociable tests are like aspirin that gives you more headache than you already have. So in order to have decent balance, the test pyramid can still be considered a useful model to consider for developer tests. It allows for a good balance between solitary and sociable tests. Now, when we look at solitary tests, also called unit tests sometimes, there are basically three ways to verify the outcome of a test. First, we can verify the state of an object. Secondly, we can verify the return value of a method that we call on an object. And thirdly, we can verify a value passed to a collaborator of our subject under test. And that's it. Those are the only three ways to verify the outcome of a test. And this results in two popular styles for solitary tests: state verification and behavior verification. Let's have a look at state verification first. State verification exercises the subject under test by calling one or more methods. And then we use classic assertions to either observe state changes of the subject under test, or we can verify the output returned by a method call. State verification is also known as the Detroit School of TDD. Now, I'm not making this up. This is actually a thing. You can Google it and you will find numerous articles about the Detroit School of TDD. Ken Beck's book, Test-Driven Development by Example, best describes this approach. Now, state verification has a bunch of advantages, but also disadvantages, as with everything in life. The advantages of state verification is that those kinds of tests are not impacted by changes that don't alter the outside observable behavior of the subject under test. That's an expensive sentence to mean that it's very easy to refactor our production code without impacting tests. And this comes because we have low and reduced coupling between tests and production code. In short, it's the simplest approach that we have for automated tests. However, they also come with disadvantages. State verification doesn't care about collaborators unless they cross a process boundary, and then you can use a test double. But they usually use concrete collaborators. And by using concrete collaborators, we move higher up the test pyramid. Another disadvantage is that it forces the internal state of objects to be exposed. This violates encapsulation. And also, it's difficult sometimes to simulate all possible scenarios, certain return values that we expect, or exceptions. Next, let's talk about behavior verification. This implies the ability for instrumenting the collaborators of the subject under test using test tools. Also, verifying the interactions with those collaborators. Behavior verification is also known as the London School of TDD. Again, I'm not making this up. It is a thing. You can search this on the interwebs and you will find numerous articles about this topic. It originated from the practices applied by the extreme programming community in London, therefore the London School of TDD. And the concepts of this approach are best described by the book Growing Object-Oriented Software Guided by Tests, also known as the Goose Book. Again, behavior verification has some advantages and some disadvantages. The advantage of behavior verification is that it can easily simulate all interactions with collaborators of the subject under test. It's very easy to simulate some kinds of return values or exceptions. However, there are numerous disadvantages as well. The tests have intimate knowledge of the implementation of the subject under test. Refactoring might break tests. They also violate encapsulation. Test code is more tightly coupled to the implementation. The tests themselves are more complicated and harder to reason about. However, the good news is that there are some techniques and design principles to reduce this brittleness. So this is quite a dilemma that we face. Should we choose state verification or should we choose for behavior verification? And more importantly, in which circumstance do we apply these kinds of verification? Robert Martin, also known as Uncle Bob, coined the term the uncertainty principle of test-driven development to describe this dilemma. Now, popular opinion states that we should favor state verification over behavior verification. And that is true most of the time, but not always. Neither of these approaches are perfect on their own, as we just saw. They all have their advantages and disadvantages. There's no such thing as the right school of test-driven development. We need both techniques. We need the proverbial middle ground here, because a balance between both techniques is a good thing. Not every object in the system has the same role or responsibility. So we should use deliberate practice by means of code katas, for example, trying things out, making mistakes to learn about when to apply which approach. We should never allow ideology to take the upper hand. When I tried to apply state verification and behavior verification, I use state verification for algorithms, business logic like domain objects, etc., validators, static or extension methods, etc. And I use behavior verification when testing the behavior is same as testing the implementation. When a subject under test interacts with collaborators that cross a dependency inversion boundary, for example, basically means delegation or interaction logic, like services, controllers, or gateways. Again, we have to find a balance between state and behavior verification. Now, let's talk about testables, because there's a lot of misunderstanding about testables. First, what is a testable? A testable is a type of object that replaces a collaborator of a subject under test just for executing tests. With testables, it's very easy to manipulate indirect inputs, and it's also very easy to verify indirect outputs. And there are several types of testables. First one is a dummy. A dummy supports a certain interface that is expected by a subject under test, although it never gets used by the subject under test. It doesn't provide any behavior or return values. It just exists. Next type of testable is a stub. Say the stub is the same as a dummy, only it returns any kind of value for query methods, or it can raise an exception. And this is the most used type of testable. The next type of testable is called a spy. Spy is the same as a stub. It returns values for query methods, but it also captures indirect outputs of the subject under test. Afterwards, a test can fetch those indirect inputs for verification. The next testable is the most well-known, called a mock. A mock is the same as a spy, but more intelligent. It also returns values for query methods. It also captures indirect outputs of the subject under test. However, a test can configure certain expectations, and afterwards a mock verifies the outcome according to those expectations. So, in short, a mock can fail a test, while a spy cannot. And then there's another kind of testable, and that's called a fake. A fake simulates the exact same functionality and behavior as the real implementation. It's not controlled nor observed by tests. The only thing we have to take care for is that the fake implementation needs to be kept in sync with the real implementation. Now, the testables on the left are mostly used by solitary tests, while a fake is mostly used by sociable tests. Now, when it comes to testables, developers need to be more accurate. Because when working on software, we need accuracy. Accuracy matters a lot in our profession. And when a developer talks about mock, it can basically mean any kind of testable. It can basically be testables in general, or it can be even something else. So accuracy matters here, because the different types of testables that I presented here have different characteristics, and therefore they behave differently when it comes to coupling between tests and production code. And that's very important. Testables are useful, so we should also use them wisely and appropriately. Now, let's have a word about test-driven development. It might come as a surprise to you that there are two different approaches to test-driven development. One is called inside-out, TDD, and the other one is called outside-in, TDD. Let's have a look at inside-out test-driven development as the first option. The approach goes like this. We start with the smallest unit of code, like a class, or a module, or a component, and then we follow the process of red-green refactor a number of times. And that way, each part of the system is created using the TDD approach until the whole feature is built up. And when we get there, we add a few sociable tests in order to verify these interactions between all those smaller parts. Some observations about this process is that there's not much upfront design. And the design happens mostly during the refactor step. So we basically start at the bottom of the test pyramid and work our way up. Now, when we consider an hexagonal architecture as an example, we start from the domain and we work our way towards the outside layers of the application. Again, inside-out test-driven development has advantages and disadvantages. The advantages are that you have the ability to work in very small increments. This approach also prevents over-engineering, and work can be easily distributed within the team. The disadvantages are that by focusing on individual parts, there's a higher risk that those parts are not working correctly together. And that sometimes might require some rework. And it can also potentially lead to a large refactoring step. Now let's have a look at outside-in test-driven development. The approach goes like this. The different parts of a feature are put in place while writing a first failing sociable test. And when that's done, then we red-green refactor. And we follow the process to test the individual. Some observations about this technique: that sociable tests serves as a beacon, making sure that nothing is forgotten. The design happens mostly during the red step of writing the sociable test. The refactor step becomes more shallow. It's more about refining the design. In short, we start at the top of the test pyramid and work our way down. Now, related to outside-in test-driven development is the concept of a walking skeleton. The walking skeleton, by the definition from the Goose book, is stated as an implementation of the thinnest possible slice of real functionality that we can automatically build, deploy, and test end-to-end. Sociable test exercises, in this case, an entry point at the system boundary, like a controller. Solitary tests are then used for further fleshing out concrete implementations of the individual classes, modules, or components. When we look again at the hexagonal architecture as an example, slices are going all the way through the application, from the external boundaries right through internal boundaries. We verify whether a particular vertical feature is working correctly, and we also verify outside dependencies of the system, like database, file system, a message queue, etc. And these slices complete the walking skeleton. Now, an extensive use of test doubles is sometimes wrongfully being associated with outside-in test-driven development. You can use outside-in TDD with concrete objects. It's also perfectly fine to only temporarily use a test double and replace it with a concrete object afterwards. So it's okay to replace a test double if that improves the tests. It's also okay to replace a concrete object with a test double to prevent cascading failures. So when it comes to outside-in test-driven development, there are, again, with everything in life, advantages and disadvantages. The advantages of outside-in TDD is that the design starts much earlier in the process. And it also encourages design thinking. The disadvantages of outside-in TDD is that it takes more time to write the first failing test, because our first test is a sociable test and not a solitary test. And it may lead to over-engineering. Now, the good news is that you don't have to choose. These practices are not mutually exclusive. We should practice and master both ways of writing tests. One of the questions that I get asked the most is that what makes the unit, or what defines the unit in a unit test? And in order to answer that question, you should have a look at boundaries by association. Now, what defines the boundary of a test? Let's say we have a class module or component named A, and it uses the functionality of some other parts called B and C. Then, in this case, there are 4 options. A test drives the behavior of A using concrete instances of B and C. That's the first option. Second option is that a test drives the behavior of A using a concrete instance of B and a test double for C. Third option, a test drives the behavior of A using a test double for B and a concrete instance of C. Or, final option, the test drives the behavior of A using test doubles for both B and C. Now, which approach should we use? A useful way is to think about the specific nature of the associations involved. And this is where the concept of composition and aggregation comes in. Now, if we consider A, B, and C again, when inlining the functionality of B and C into class A, when A would still be cohesive, then we end up with composition. And this is quite prevalent in CRUD systems, where we have lots of I/O in mostly isolated features. Now, when emergent design is what we want, then this is more suitable for inside-out test-driven development. Now, when inlining the functionality of B and C into class A results in A to be no longer cohesive, when inlining violates the single responsibility of A, then we have aggregation. And this is what you typically see with more complex domain models, where you have more interactive features. And this requires more design upfront, which is more suitable for outside-in test-driven development. So we have to find a balance based on the associations between classes and components and modules. Did I mention yet that we have to find a balance? Now, we merely scratched the surface in this talk. We haven't touched on other topics like the anatomy of tests, the dry and damp principles, transformation priority premise, decoupling patterns, observational patterns, design principles for automated tests. And as we saw previously, test-driven development and software design are two sides of the same coin. Therefore, we can also talk about clean architecture or hexagonal architecture, functional architecture, event architecture, etc. I want to close off with some resources, and then we have some time for questions. Some of the books on this list I already mentioned. The other book that I want to highlight is called X-Unit Test Patterns by Gerard Mezeros. This one is boring as hell. It's very thick, but it's very highly recommended. Every single pattern that you can come up with when it comes to tests is described in that book. Again, takes some effort to get through, but it's gold on paper. And then there's also my book. It's also boring as hell. No, really. It touches on all the topics that we discuss and much, much more. You can find the ebook at LeanPub. The debt-free version can also be found at the usual bookstores. Something I like to mention about my book is that it's completely self-published, and all the proceeds are donated to animal welfare organizations, so I don't make a dime on this book. I also provide a 2-day practical workshop. And in this workshop, you'll be able to learn and practice in a real-world code base. You can have a look at my website or drop me a message if you're interested in this. So my name is Jan van Ryswyck. I'm the founder at Principal IT, where I am a technical coach / mentor in extreme programming practices. You can find me on Mastodon. I'm also on LinkedIn, and my website is at principalit.eu. I would like to thank you for attending my talk, and I wish you a very nice conference, and I'll be available for questions on Gather. Thank you.